The ultimate goal of this project eventually was to look into a digital design workflow which is fully automated, from a 3D body scan to the computational design algorithms to the final 3D printed geometries which are 3D printed in multicolor directly on the textile. The Arid collection focused on a world which is between the oceanic and the arid environment. The 3D printing method directly on the fabric allows me to kind of create a different perspective of the kind of colors from different angles. So when the fabric is in motion, the colors shimmer in a variety of different effects, and that adds another dimension to the layer of the 3D printing on the fabric.
We utilize generative and computational design processes to create the final outcomes, which consisted of 19 main parts as well as an additional 19 accessory parts. Altogether, we had 172,000 mesh pieces. We use meshes because they're versatile, lightweight to process, and are the final output for the printer. We mapped about 15,000 colors onto those meshes, which is something that we're only able to do with Stratasys multicolor 3D printing technology.
I came up with this idea because one of the challenges of consumer 3D printed fashion is the practicality and wearability of the garments. I think that 3D printing on fabric holds the future in fashion because there's a layer of textile between the 3D print and the skin. I think what was unique within this process was that I had 4 technology partners, each individually specialized in their own fields, and that added a new way of collaborative co-research to the workflow. Re-FREAM allowed me to reflect on looking beyond the aesthetic approach. It allowed me to look into rethinking the way of how parts are being connected and coming up with an entirely new, innovative way of joining the modular system in an organic way by looking at the female anatomy and the way of how muscles are being structured in the body and kind of taking those lines and seams into the way of how the elements are combined in the garment. I see the future of this project to take this idea of digital Vogue between organic and synthetic processes to another level. Eventually, this evolved into the development of the JK3D series, which is about this idea of a cascading method where you don't have just only one 3D printed dress, but eventually you have a garment which is in its essence a whole collection. It can be a jacket, a skirt, a versatility of accessories, rings, necklace, a corset, a handbag, and therefore you can actually make it more customizable and bring it to a mass market. It aids to the future of urban manufacturing in a larger scale.
Our research was focused on adhesion of 3D printed structures on textiles, possibility of printing on both sides of textile, and together with Julia, we developed a process enabling printed snap buttons on textile. I think we contributed with a big puzzle stone to the future of customized and printed fashion.
And today we're working on a local production instead of global. We want to transport as little as possible. And for sure, we want the consumer to be able to complete his own garment by himself. And I think you solved it in a wonderful way with the little buttons and with the joinery snaps. And I think this really represents the thinking of our time.
As a development and design engineer, I appreciated a lot seeing how Julia works with blending both aesthetical and functional surfaces and elements in the same design. So in the end, we end up with a product that is highly aesthetical and with a lot of functionality at the same time, and all blended in for a very optimized and awesome result.
By working together with artists, we find new ways of using our simulation software in a more creative way, and really integrating it into the 3D workflow together with parametric design tools.